This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
If you're worried about not getting one of the revision booklets that have been emailed to you, there's two, right? You only would have picked up one because Michaela got in trouble for killing 3 trees, basically. So if you've got your laptops or iPads or whatever digital device of your particular preference is, you can pull them up if you desperately want to. I'm going to be alt-tabbing between 2 sets of stuff. One's going to be like my stuff, basically. The other one's going to be past exam questions, where all of the examples I've picked out, except for one, less than 50% of the marks were rewarded, awarded, achieved, got, whatever. So yeah. Wondering if I should start without that guy or not. Does anybody have any friends that they know are coming but aren't here yet? No? That's good. Test. Test. Yes, there we go. All right. All right. Okay, here we go. So, hope your lunch was good. To be honest, don't particularly care, because it wasn't my lunch. My lunch was fine. I got pizza, haha. All right, so, here we go. As the more astute of you may have noticed, I'm not Mary Papp. I've been tutoring methods since I left high school in 2003, and I've been teaching it for the last several years, and I've been marking exam 1 for the last couple of years. So I kind of know what I'm talking about. As a general rule, Mary and I agree on about 95% of everything. The last 5% is like personal preference things, which I'll go through in detail when we get to it. But I'm an okay surrogate for Mary. Cool. Oh, before I get into this, how many of you guys are Year 11/Unit 1-2? Cool, and by elimination, how many of you are Year 12/3-4? 3, much better than the last one. The last one was about a 50-50 split, so I was confused, but apparently you're all in here. Cool, okay. So, first thing, you know that the exam at the end of the year is on Units 1, 2, 3 and 4. Is that news to anybody? That is news to you? Okay, guess what? You've got to revise the last 2 years of stuff. Congratulations. At least you know now. So, I'll get into a bit more of that. Something that's worth knowing. There is a lot of assumed knowledge in methods. This stuff, so about 90% of people lose more than 10% of their marks on what I call dum-dums. Okay, so this is fraction operations, so just fractions. It's not like, oh, it's a fraction operator on a matrix of whatever. No, it's just like a half plus 3/4 fractions. Decimal operations, expanding and factorising. I'm not talking about factorising for like a polynomial of power 7. This is like quadratic, Year 11, or Year 10 even. Simplifying, just fractions and stuff, or just surds, stuff like that. Using your CAS I'll get to later. Common examples from 2017. 5 times 6 is 36. That's good. Hey, right? All of these, like for them to be common, means it wasn't just one person that did it. That's weird. Okay, I don't know how this is possible. The only one I can kind of get is the 30,000 over 16, because you don't know your 16 times tables. Okay, they do divide by 2 for a start. You can probably work it out from there. that ends up being an integer. You will get 1 mark for an answer, unsurprisingly. If it's worth any more than that, I need working shown. If you can't simplify stuff, you ain't getting that answer mark. Right? You're throwing away 3 marks for this sort of stuff. It's just, come on. Generally, all the markers are pretty nice. There's 70 of us in a room that have to figure out how we're going to mark it. We all have to agree. So if you're doing this stuff, funnily enough, we're like, nah, son, you lose the mark. Okay? Very true. Okay? There are some very, very interesting answers that come up year after year. Don't be one of the interesting people. All right? Be statistically significant because you're up on the, on your side, up on the 99th percentile. Don't be interesting for me in that I go, that's something I'll put on the examiner's report. Okay. Happens a lot. Don't do. Okay? Very, very simple. Oh, by the way, if at any point you have questions or whatever, just flag up and I'll stop and I'll talk to you and whatever. Cool, cool. Exam structure. I'm hoping you guys know this already. You got 2 exams, so don't turn up to just one. First one, non-tech, you versus the paper. Second one, tech, you get your bound reference, which is basically a security blanket. The structure is pretty much 10 questions in exam 1. It's always 20 questions in exam 2 and 4 or 5 extended. So the non-multiple choice will have A, B, C sort of sections. That's what the with parts means. Based on that, how many minutes per mark do you have? Okay, the fact that not everyone can immediately tell me that is slightly worrying. You should know. You have 1.5 minutes per mark. How long should your practice, how long should you practice to get to? Less than 1.5, right? Because if it's taking you 1.5 in practice, when you're actually in the exam, it's probably not going to take you 1.5, right? Aim to get as close to 1 minute per mark as you possibly can. Right? Some questions are easier, some questions are harder, so it's not going to be exactly 1. Fine. Try to save as much time from the easy ones so that you can spend it on the harder ones. Big surprise, right? Yes. Cool. All right. Whole lot of general do's and don'ts. Most of my time is going to be spent on this. So funnily enough, I put the important stuff at the front, and then we're going to run through a whole lot of other stuff. What I've got is, on the side, you see a whole lot of letters and numbers and things. They say the year of the exam, whether it was exam 1 or 2, and then what question. Right? Every one of these, that I'm going to, then there's lots. This is going to be the second set of slides that you've had emailed, but I'm going to swap to them in this. Every one of those, less than 50% of the marks went out. For some of them, less than 30% went out, and for a couple less, there's one in there with 2%. I think 2% of people got top marks, something like that. So I've picked the things that people tend to stuff up to try and give a good idea. So ATSQ, how many of you were here in the middle of the year when Mary was around? Yeah, most of us. What does ATSQ stand for? Oh, you didn't listen to Mary. Bad. Mary's the chief examiner. Listen to Mary. Does anyone remember? I heard something. No? No one's brave. Oh, we're all cowardly. Okay. Answer these. Sorry? Answer the specific question. Right? Answer the specific question. Every year, kids answer a question, usually of their own devising. So, oops. Go, this one. For example. Okay, here's some stuff. Great. Such that the distance to the point of the origin is at a minimum, and find the minimum distance. Whole bunch of kids. Only 14% got 3. You guys know how to read the examiner's report tables? Yes? Yes, I'm getting a lot of nods. Cool. Only 14% of people got full marks. Why does that happen? Others had the correct answer for C and D, but did not work out the minimum distance. They did all the hard stuff, and then just didn't go, therefore the minimum distance is this. Free mark. But they've just gone, nah, I'd rather not have it, thanks. Okay. So, always, particularly if it's a 3-mark question or more, once you're done, read the question again. It takes 5 seconds to reread it. and you'll very quickly catch, oh, whoops, I forgot to do this, and just tack it on. Right, 5 seconds gets you a free mark, sweet, it's worth a minute and a half, it's taking you 5 seconds, that's a win. Go. Oops, go back. Go. Oh, more examples of this, that's right. This one was a very interesting thing to mark that year. Without the context, like you can go back and look at the context in your own time, but basically you had to come up with this integral from d to 70, had to equal something, solve for d. Fine, it was on exam 2, so you had your CAS, nice and easy. People came up with all sorts of interesting things, and they did solve what they came up with, and that was fantastic. They got 0 marks because it had absolutely nothing to do with the question that was actually asked of them. Right? Make sure you're answering the question on the paper. It is common for people to answer something that's vaguely kind of similar. I can't give you marks for something that I didn't ask you to do. Right? You can't go, oh, all right, 1 + 1 = 2. I mean, yeah, that's true, that's nice. It's got nothing to do with the thing that was asked. Always check what you're actually doing. Once you've done what you think is the right answer, read it again. Similar thing. So, with this at the end, others gave approximate answers. Why you do this? You don't do this, right? Mathematician, exact, rigorous, perfection, that's what you're after. That's what I'm after, right? And Mary even more so. So, make sure you're doing things in exact unless it asks for decimals. If it asks for decimals, fine. Go off to like crappy engineering land. This is math. Math is nice, precision, perfect circle. This is what we like. Okay. Oh, there's a couple more. Cool, this sort of thing. And this is what I'm talking about. They'll answer their own weird question. Okay, for what values of k does gk equal the inverse of gk? Some people made them equal and then attempted to find the discriminant. It's like, there's no discriminant in the question. What are you doing? Why you do this? Right? And it's just because somewhere when they've read the question, they've warped in their mind something and they've turned out to just try and find the discriminant and then stopped. Right? Answer the actual specific question. I'm not saying this because this is just hilarious. 95% of people got 0 marks on that. To be fair, a lot of them got lost before they even got to this question. Right? But there are heaps of people just throwing away marks. Right? You can easily beat averages, right? Just by being slightly less stupid. Right? You don't have to be super fantastic, just be slightly less stupid than the average bear. Okay. Show. Do we know what show questions are? Yes, lots of nods. What do you do in a show question? You show why it's true. Okay, I mean, it's really technical stuff, right? But you show why it's true. So, this sort of thing. Oh, wait, no, next one. That was another one of those. Is that one? Show, yes. Cool. Show that x1 is less than x2 implies that g of x1 is less than g of x2. Okay, fine, with some definition-y stuff. Some just substituted in specific values. I want to show that something is being less than something implies something else. If I just pick 2 is less than 3, I'm going to put 2 into the function and 3 into the function. Oh, look at that. The function of 2 is less than the function of 3. That's nice. That's a specific case. That does not show the generality. So, whenever you're doing a show question, solve the thing and check your answer matches. That's all the show question is. You're still doing the question as though we didn't give you the answer. It's basically like having your textbook questions, and it says, here's a question, right? You do the question, and then you check the answer in the back. That's what a show question is like, okay? Basically ignore what it says to show and just solve. Get to the end. If your answer is the same as what you were supposed to show, then you're probably good. If your answer is different, then obviously have a rethink, because if you're getting a different answer to a show question, you're definitely losing marks. So yeah, you just want to go through, solve it as you normally would. Yeah, mate.
We can end with or start with the show thing though, right, and work back to like somewhere else.
You can. It's generally a more dangerous thing to pull off because of the non-reversibility of some processes. So it might deductively work, but then when you try and go back up, you might end up with, so say, like for derivatives versus integrals, right? If all you have to do is derive and show that it's this, if you start at the thing and then work back, you have to integrate. You might end up with things that you can't even integrate to get back up there. Stuff like, does that make sense? Yeah? So generally you want to start as though you didn't know what it is you're trying to show and solve. It's easily the safer way to do it. You can technically go backwards, but you're asking for more trouble. But you can. Your exam, you can do what you want. You can throw away as many marks as you see fit. Cool. Show question. It's worth 1 mark. Generally, if something's worth 1 mark, it's an answer mark. And that's it, right? I don't care if you, like, I don't know, solve the beginning of the universe or something, right? If you can draw like, oh, the Mona Lisa or something, fantastic, that's beautiful. I can't give you any marks, right? But, so generally, for 1 mark, it's just going to be the answer. If it's a show question, though, these suck because it's only worth 1 mark and you have to write more than one thing. Most kids on this one, a common pattern was to go straight from the first line of differentiation immediately to the final line with no indication of obtaining a common denominator or any other steps. I gave you that answer. If you just tell me the derivative of this is that, I know nothing about what you can and can't do because I already told you that. That don't count, right? You have to go through, and this is a little bit painful, but as a general rule for show questions, put in more steps than you would otherwise normally do, just so it is abundantly clear to us that you know exactly what you're doing at every step of the process. Because a whole lot of kids that year jumped like 2 or 3 steps at a time, and we have to agree among 70 people what we will and won't accept as sufficient working. Right, and that's hard. Yeah, so show questions, if anything, err on the side of overdoing it. I know that'll waste like 5-10 seconds, but if it's 5-10 seconds to guarantee a mark, it's worthwhile. Cool. Hence questions. Do we know what a hence question does? Yes? Right, use the previous thing. Right, if it says hence or otherwise, you can choose. But if it just says hence, you have to use the other thing. Right? If you leave it out, then we're in trouble. So, this thing, hence calculate this integral. I give you that integral in method. Hands up if you're spesh. Cool. Don't answer this question. Can you integrate that from methods? You don't have rules to do this. You don't know how to do this. That didn't stop a whole lot of kids trying last year? Yeah, last year. Right? That didn't stop a whole lot of them going, yeah, all right, I'll have a crack at this, and then they write some garbage, and it's like, yeah, funny enough, that's wrong, because you never learned how to do integration by parts from spesh. You're in methods. Hence, use the thing that was immediately above it. Okay, definitely look at these questions. Oh, they are really interesting to look at sometimes. Painful is another word for it. Yeah, ignoring the hence instruction. Probably a bad strategy. Go. Label coordinates with an S. I've underlined it, I've bolded it. It won't appear in the exam like that, unsurprisingly. Right? You have to see the words coordinates and look for the S. Okay, it's English, you're expected to be able to read the plural. 16.2 2CS. So, we had a whole lot of stuff going on. We've got tangents, we've got normals. We had a whole lot of stuff to figure out. Find out the coordinates of D. That's the coordinates with an S. Worth 2 marks. And so by the time people got to the end, they got da-da-da, and X is -1. Beautiful. And then stopped. Heaps of them stopped. And then some of them actually gave the incorrect coordinate for Y. At least they tried. But a whole bunch would just go, therefore X is -1. Beautiful. Next. Right? They didn't go back, read the question, go, whoop, coordinates plural. All you have to do is sub -1 into a function. It's a nice, easy number to work with. Right? You're throwing away these easy marks. It's so painful. But, yeah. So yeah, make sure you check whether you need multiple coordinates. More often than not, you'll need both. Cool. Use something to do something. If the question says use calculus to find whatever, it's giving you a really good idea of what to do. You use calculus to do the question, right? Actually use it. There are some cases where there will, in methods, where you'll have potentially 3 or 4 options and it will say use this method, so use calculus to do this. The reason they'll do that is one of two things. Either it'll make it a lot easier, right? And if you use another method, you'll end up in really weird territory that takes forever to cancel stuff out or something like that, or it's hard to simplify. Or you'll end up at just a strict dead end. So you might be trying to integrate something that isn't integratable in methods. So if it says use this to do this, it's telling you, you might get stuck here, I'll give you a clue. So if it says use something, use it. It's actually trying to make your life a little bit easier, most of the time. Cool, simplify things. As always, simplify your fractions. You should be able to do that. You are allowed to leave an irrational as a denominator in methods. If you're in spec, you're not. So be careful about that, spec people. If I say spec people, that doesn't sound nice, but anyway. So irrational denominators are okay in methods. They're not okay in general mathematics because they should be rationalised, but you can get away with it in methods. Cool. Exact versus decimals. As a general rule, you should be doing everything exact. However, if the question says, at the bottom of it, correct to 4 decimal places, guess what? You have to give it in decimal places. Most of the time, when you put it into a CAS, you'll get some garbage result, and you'll be like, oh, I can't write that. Roughly, what is this equals? And you get your decimal. This was one of the times where it actually gave you a proper answer, and you're like, oh, I can actually write that. But the question asked specifically for correct to so many decimal places, so a bunch of kids lost out marks because they left it as exact instead of convert to 4 decimal. So always, once you get your answer, go back, read the question, make sure you've actually satisfied accordingly. Rounding, this one was weird. I've done this question 2 or 3 different ways, trying to figure out why people rounded this wrong, and I just couldn't. So ultimately the answer should have been an interval ending in 0.11, but heaps of people put 0.12, and I have no idea why. Like, you're in year 12, you should be able to round. It's like, what, when do you do rounding? No, not grade 1. What are you doing? You liar. No, you do it in somewhere in primary school, but, I mean, I can't figure it out. I can't figure out what they were doing that year, but heaps of them did it, and I cannot figure out why. You should be able to round. Cool. Other things, graph sketching. So, grid. If there's a couple of times that they'll give you a grid to sketch on, if that happens, your sketch has to be at least roughly to scale. Right? Be careful about that. For hair, so what do I mean by hair? Is that up? Yep, cool. Hairy graphs. Let's say I'm trying to sketch that, right? A hairy graph is when instead of doing it in one nice line, you go, oh, I'll do this, and it goes a little bit like, yeah, then it comes down a little bit, and then you go, oh, no, make sure that's flat. Yep, good, and then up, 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 up. It's fuzzy. Right? It's a hairy graph. It's what Mary calls a hairy graph. She hates hairy graphs. Right? Shave your graphs sounds really odd. Don't do that. So make it a nice, one continuous smooth thing. If you're not drawing your graphs in pencil, I'd suggest draw your graphs in pencil. Because funnily enough, when you draw it in pen, it's a lot harder to change. Don't do this sketching, particularly with trig. Particularly trig graphs. Heaps of people seem to really like hairy trig graphs. Just one nice smooth curve is good. Overlay. Overlay is when you have, let's say we've got the same shape, and they go, it's like, oh yeah, that would have been fine. And they go, oh no, this should have been actually a little bit lower, and then this should have been a bit higher. So it's a bit more like that. And then this goes, yeah, that goes, oh actually this should have been about there, so we'll go there, yeah, that's good. And then this. Cool, that's good, that's good. Oh, actually, this should be a bit more like there. This should be a bit more here. That's actually up there. Oops, oh, there we go. Yep, there. There we go. Oh, I don't want this hair, so I'll do this. Now I have an entire interval. Brilliant. That's no good to me, right? Because now I'm going, okay, where's this? Particularly if this is on a grid. Well, now I've got, this is 3 to 4 is somewhere is my x-intercept, and this is wherever to wherever. This is wherever. It's terrible. Pain to mark. So, don't overlay. Don't put 7 graphs on top. Draw your graph, make it reasonable, If it's no good, get an eraser, go again. Right? Don't draw 17 graphs, like erase 17 versions of it just to make it like nanometer precision. You don't need nanometer precision, but like make it a half decent graph. That's fine. Key features. Make sure you label all your key features, turning points, intercepts, all the good things. Generally, you don't need to label inflections because they don't put them on, is what I've noticed for several years. Having said that, you should be able to do it. There is one thing worth noting though, so let's go, we'll go this slightly less bad one. So we've got 2 turning points here, intercept, 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 intercept. So you label all those and you're happy. Fine. Okay, if you label, say, this point out here, and let's say this was, I don't know, 2, 5, and then I label this, I don't know, 4, 8. There's a bit of a problem there, right? How can that possibly be true? Right? Probably not going to be that obvious, right? But if there is a point labelled, even if it's not one of the ones asked for, if there's a point labelled that isn't correct, you will lose a mark. You lose a mark for what's called over-engagement. So if you do stuff extra to the question that you're not asked to do, right, and it doesn't make sense, then you lose a mark. So don't say things that aren't true, is the general thing. Does that follow? Yeah, I'm getting nods. Cool. Okay. Cool. So this question was done horribly last year, in my opinion. So we had a function. It turned out it was actually only defined between whatever it was, -3 and 0. That was the grid you got to draw on, though. So we gave you enough rope to tie your own noose, essentially. Because we gave you a lot more space to draw whatever random garbage you came up with, if you came up with random garbage. All right? You had to figure out, oh, no, my graph, I can't remember, the domain might have actually gone through to, I can't remember. But it definitely stopped at 0. And the reason I know it stopped at 0 is because of what people did around 0. So most people got your turning point just fine, and then they had the point 0, -4, but this thing was a cubic, and they decided to make this look like a quadratic. So they just had the whole thing just go shoo, because they just calculated, oh, at 0 it goes to -4. They didn't figure out, oh, it should actually be a turning point at 0, -4. So they didn't get that extra concavity. If I say the word concavity, do people know what I mean? Yes, good. So curviness, basically. They didn't get that right curve going for that bottom bit. If that inflection wasn't implicit in there, you lost the mark. Okay, so when you draw the graph on a grid, it has to be roughly the right stuff. Cool. It doesn't have to be centimetre perfect or any of that, but if you've got, so this is supposed to run through what? Somewhere around -1, -2. If that ran through -1, -2.5, fine. If it ran through -1, -1.5, fine. If it ran through -1, -0.1, we'd have a problem, right? Because that's substantially far away from where it should be. But it definitely had to have that turning point nature at 0, -4. Cool. Heaps of people lost things for that. Common errors, the domain was wrong. Many of them look at like inverted parabolas instead of a cubic. Yeah, stationary point should be that 0, -4 stuff. So stuff like that. Check the validity of your answers all the time, every year. You get these really, really weird answers. But for this, to be fair to the kids this time, this was not a straightforward question. It took a lot of fiddling around and thinking, as the 90% of people that got 0 marks can probably attest to. It wasn't straightforward. This part that sucked about this was 5% of the population got 1 out of 2. It was very hard once you got, so I should restate that. If you got 1 out of 2, you were probably really close to 2 out of 2 actually, because your actual answer should have been 1 is less than k is less than or equal to 5 on 4. Heaps of kids put 1 is less than or equal to k. That one little horizontal line cost them that mark. They'd done everything right, all their working was beautiful, but then they hadn't checked whether or not those endpoints were actually valid in the original setting. Take the 10 seconds, once you answer your question, go back to the start, read it again, make sure your answer makes sense for it. So that sucks for them. But we have to split you guys apart somehow. So yeah, check your answer, make sure it makes sense. all those good things. Particularly good ones, was it last year or the year before? This one, same sort of thing. If for a lot of kids, they were putting domains and ranges that made absolutely no sense. Like you put them back into the original, and you can look up these exams in your own time to see exactly what I mean. But some of the answers they were giving were just like, this can't possibly be right, and it's abundantly clear. So if you take 5 seconds to look at your answer, look at the question, you go, no, that doesn't make sense, hang on, and then you check. All right, so basic stuff like that. The ones that are really good that Mary loves are probabilities that are outside 0 to 1 that are sometimes in the hundreds or the thousands. So it's like P is the probability of something happening. P is 2,845. I mean, that's pretty likely. Okay. Doesn't make sense. Think it through. Doesn't take that long to notice. Notation 17.1, 17.1.7a. There it is. This is a really straightforward question. It's only worth 1 mark, and yet more than a third of the state drop a mark on it. This is so straightforward. What most of the people did when they dropped that mark was instead of that being a hard bracket 1, they made a soft bracket 1. They just didn't think about the endpoint. Right? It's really depressing, basically, to see that happen. Because you've done the work and then you've just not thought it through. Legibility. A lot of people like to write in those paces, those pacer pens. You can do that if you want. Don't use the light leads, because at the end of the year, the way we get these things to mark them is they are photocopied and then sent to us. If it doesn't come up on the photocopy nicely, it makes it really hard for us to mark it. All right? So you want to write it deep enough so that it actually comes up. Yep. So Mary would want you to do everything in pen. I find that not necessary, except for graphs. She wants you to do everything in pen except for the graphs, which she wants you to do in pencil. When I do my exams, I do everything in pencil. Right? What matters, you can do either. Right? What matters is that it is legible. Right? The reason I do everything in pencil is because if I make a mistake, which obviously I never do, if I make a mistake, I can rub it out. Right? If I do it in pen, I can very quickly run out of space on an exam paper. Right? If you want to use pen, go for it. That's fine. If you make an error, as a general rule, don't try and salvage half the page, right? Because it's just going to get progressively uglier and worse. And then if you make an error on top of an error, it's going to get even harder to find and bad. So just go, nah, start again. Right? But you're free to do whatever you want. Because funnily enough, we're trying to mark the math. We're not trying to mark the choice of utensil. I would suggest pencil. Mary would demand pen, but she has to accept pencil. But since you have to use pencil to do the graphs anyway, I'd suggest use pencil for the exact same reason. You can rub it out, do it nice. Don't write something, rub it out, 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 write something, rub it out. If you're struggling to read it, good luck with me trying to read it. Right? I'm one of, if not the youngest exam markers. Right? I've had glasses since uni. My eyes are terrible. They're older than me. Good luck. All right? You want to make it legible after photocopying for someone with bad eyesight. Keep that in mind and you should be fine. There's a lot of people that write, particularly in Pacer, they write tiny, tiny characters. It's like, yeah, now I can get more working in a tinier space. That's great. I can't read anything of what you're writing. Okay, make it clear, make it legible. Make your examiner happy is a very good default rule. Okay, if I'm happy, that means I'm like, yes, this person deserves marks. If I'm getting annoyed, that makes it harder for me to stay totally unbiased, which obviously I'm never biased, but don't push your luck. So legibility is very commonly a concern, particularly the way that some digits and letters are written. Pi for, it seems to be a Chinese thing from what I'm noticing. Pi's tend to look a lot like X's when they're writing fast. And that's really problematic when you've got a function that has pi's and x's in it. It becomes really hard for me to read. So that's one example. So just make it clean, make it sweet. When in doubt, draw a graph, or draw an image, draw something. So when you don't know what's going on, draw a picture. There are heaps and heaps of examples of this, and we'll come up to one later, where drawing a graph had a very high correlation, sorry, not a graph, drawing something had a very high correlation with getting the question right. So when in doubt, draw something. Commonly, you can even get marks, even if you're not asked to draw anything, commonly you can get marks for that as working. So at least it shows some understanding of what's going on. Derp, derp, derp. So these are dum-dums, right? So this is the sort of stuff that I'm talking about that just do. No. This guy. First question. Literally, first one. 1A. First question last year. Every year, this one's this pair are the only two that are above 50% of the marks went out. Because the first question, every year except this one, 75, 80% is usually the average of the marks that went out. This year was particularly bad. I don't know why. They weren't any harder. If anything, they were slightly easier. People were just doing dum-dums. So what they do is this x plus 2 and x plus 2 on the top and the bottom, they're like, yeah, cancel. No, don't cancel. You've got a minus x up there as well. That doesn't cancel. You're bad. You lose mark. No good. The second one, sometimes people, and this is the stuff that makes you go, oh, 2 over x plus 2 squared. That's beautiful. That's nice. It's sweet. It's controlled. It's sweet. And then they try and expand the bottom. Why? Why you do this to me? Now I have to make you lose a mark. Because if you expand it, it's fine, if they expanded it correctly, but it's an extra thing they can stuff up. And unsurprisingly, some people decided, yep, that's x squared plus 4. Hey, good job. Killed a kitten. Fantastic. Right, you definitely deserve to lose a mark if you kill small mammals. So, yeah, don't do that. 1B. Same sort of thing. People were just doing random things. Sometimes it was really weird. Sometimes they'd lose a negative. Sometimes an extra negative would appear. What else was there? There was something else really weird. Oh yeah, some people tried to expand. Yeah. You started off with a cubic or something, and some people tried to expand the cubic before deriving it, or something really weird. And so, funnily enough, they'd stuff up expanding the cubic. And then, bad, just ugly. And then other people forgot to actually answer the question. So the whole thing says, okay, here's this, evaluate the derivative when x is 1, right? And they do the derivative and then go, oh yeah, I'm done. It's like, just read the question for 2 seconds there, champ. Yep, congratulations, you've lost a mark. All you had to do was sub in 1 and simplify. That's, 1's pretty convenient. That's why this is on the first question, because 1, nice, we're trying to throw marks at you. And some people go, no, I don't want your marks. Have your marks back in your face. So, that's the way that goes. This is a quote from, I can't remember if it's Mary or from the examiner report. It's the same thing. Mary writes the examiner report, like the final thing. So, we as in markers, can make 0 assumptions about what the candidate, you, might have meant to write. I can be very certain that you know what you're doing, and then you just made some dum-dum. I'm not allowed to assume that when I mark. Right? Whatever you put on the page, I have to assume this is the sum total of your knowledge. Right? So if you do a dum-dum, I have to go, you were dum-dum. Okay? I can't do anything else about it, because it's unfair to everybody else that isn't doing dum-dum. Yeah, that's basically that. Having said that, don't put the sum total of your entire knowledge on the exam paper, because that will take too long and you'll run out of time. Well, it depends how much of a dum-dum you are, I suppose. If you don't know too much, maybe you'll have spare time. Cool. Exam technique. The exam, school, everything, it's a game. Learn the rules of the game. Play the game really well. Anytime you play a game and you don't know the rules, you will lose the game. Right? Know the rules of the game. know how to do well at the game, know who plays the game well, play like them, don't play like the dum-dum. So, know how much time per mark. How much? Hey, see how much better that was than the earlier thing? You learned something, yay! Okay, cool. So you got 1.5 minutes per mark on average, right? So that means for most of it, you want to be less than that, and then when you get into typically the last 2 questions for everything, it usually takes more than that. So you need to build up that spare time early so you can spend it at the end. The number of marks per question tells you a lot about how it's going to be marked. If it's worth 1, I don't care if you solve the Riemann hypothesis, which none of you actually understand. That's a bad joke. I don't care if you solve all the mysteries of the universe if you didn't solve the actual question, right? Because if you go da 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 da, x is 3 and x should have been 2, I don't care how lovely and magnificent all your working is. If it's only worth 1 mark, the whole thing, I'm just going to go wrong. 1 mark, just an answer. That's it. On the flip side, that means you don't have to show any working. You can just go 3, done, and then you're sweet. There is no penalty for multiple choice guessing, so don't leave any of them blank. Right? Even if you have 0 idea, you can usually knock out 2. Commonly, you can knock out 3. So now you're down to a 50-50. Sweet. Right? Have a crack. You can't lose marks for it. Have a crack. The formula sheet is on the back. You should know how to read it, so definitely be familiar with it. Have it with you when you're doing your practices. Your CAS settings, check them before you walk into the room. Seems like an odd thing, but more than definitely commonly. People will do the entire exam in the wrong settings, so they'll do degrees instead of radians. Good job. It takes 5 seconds to check, just check. CAS use, so the functions on your CAS, so solve, define, all those good things. There's a lot of functions that your CAS can do. I highly recommend that you look them up and get practiced in them before you actually use them in the exam. If you are not confident with a function, probably don't use it in the exam. Seems reasonable. Know the limitations of the CAS as well, because sometimes it's an idiot. As a general rule, and this is what I tell my kids, the CAS, all it does is accelerates what you are doing. Right? If you tell it to do something, it will do it faster than you can probably do it. If you tell it to do something dumb, it will do something dumb really well and quickly. And then you look really dumb. Right? Don't do this. Right? Also, the calculator is an idiot because it will give you sometimes only 1 solution when there's multiple, or alternately it will give you multiple when there's only 1, or sometimes it'll crack the SADs and go, I don't know what you mean. Other things that it does that's a good example is you might have a function that has kx, so k times x, right, which is very, very common, turns up. If you type kx into your CAS, it thinks that's 1 variable. Right? You have to type k times x because CAS is stupid. Okay? Treat the CAS like an infant, basically. Okay? Check every last bracket, every last comma 7 times if you have to. Make sure you're actually telling it what you want it to do. Because it's a moron. Yeah. And the way you can tell it's a moron is when you check for reasonableness of your answer. Because you check, you look at it and you go, is this about right? Right? You don't have to be able to do too much calculation to be able to figure out, yeah, that's within where I'd expect it to be. That should be okay. Right? More often than not, if you do something dumb or you mistype something, the CAS will just go off on its own magical little journey and be way off over here. And you're like, should be a probability. Turns out it's 2,805. It's probably not 2,805. I missed a bracket. 0.3. That seems reasonable, right? So do that sort of stuff. For example, there's a bunch of these. So restricting the domain was one that came up on that. There's only 1 solution for this thing, and yet if you do it on the CAS a certain way, you'll get 2 solutions. So this is the sort of stuff you have to be thinking about. For this guy, you can literally type in, define your function h of x to be that, and then just type these in until eventually it says true. You can cheat, essentially, right, if you know what you're doing. You can eliminate a whole bunch of those. Similar story for this guy, you can just define stuff and go, saves you time. That's the answers to that. What's this? A lot of people for this year, you may or may not be able to, well, you'll be able to say it. So you've got x minus g of x, and g of x was defined earlier in the question. Oh, it's actually there. A whole bunch of people wrote that immediately under it when it should have been with the brackets. Right, so it's just those subtle little things. If you had a defined g of x right at the start, you can just write x minus g of x and you're sweet. All right? If you didn't define it, that's fine. Just remember, you need your brackets. All right? But if you tell the CAS to do that one over there, it'll do it. It can't see the exam question. It goes, yes, master sir. And then goes, oh, I've got no idea what I'm doing. Oh, settings. Some students have their technology in degree instead of radian mode. Right? Usually a giveaway for that, I mean, aside from checking the settings, a giveaway for that is when you get extra pies and stuff that spit out that you're not expecting. This is where you check the reasonableness of your answer. As a homework project, put your settings into radians, do a derivative of some trig function, and then do the exact same trig function in degrees settings, and you'll see what I mean. It gives it away that something's a bit sus. Whole bunch more. Same thing in this one. They actually wanted the answer in degrees, and it said that in the question, and then people left it in radians because that's the default. It's like, that's nice, but if it actually asks for the degrees, you have to be able to switch. Sorry, they do that to you. Suck it up. You have to be able to do it. Similar story with this. If you define the thing, this becomes really easy to solve. If you try and do it step by step, it'll take a bit longer. So you want to be able to use your CAS to make life fast. Again, radians instead of degrees for answers, stuff like that. Control to H, to H. Oops. This was about 94% of them got nothing because a whole bunch of them had lost the plot by this point. But a whole bunch of the kids that put in got 1 out of the 2. What they were doing was just giving an answer of 7 minutes, and that was right. It was 7 minutes, rounded to the nearest minute. It's worth 2 marks though. I need some working. But because it's exam 2, kids are just going, 7 minutes. Turn page. Right. I can't give you 2 marks for that now. It's totally the right answer, but I can't give you any marks for it. So you have to put on something that convinces me that you know what you're doing. Right? It doesn't usually have to be that much either. So yeah, if it's worth 2 marks, you have to have some working somewhere. Doesn't have to be much, just has to be something. Don't write in calculator syntax though. Calculator syntax is not math. Okay, and they do not like you when you do calculator syntax. Write proper math, go to calculator, do your calculator syntax, equals, back to math. Cool, cool? Cool, cool. No. Multiple choice cheat. This question, 17% of people got it right. That's worse than guessing. Right, so that's weird. That means people aren't doing this one right. There is a really easy way to tackle these questions. So integral of some unknown function equals 5. Then undergoes this transformation, spits out what should it equal. There is a really easy way to do these. If it's a general function, it could be any function that satisfies that condition. Pick the easiest possible function that satisfies that condition, a dead straight line. Then you can run this whole thing in about 15 seconds and get it right. Right, you don't have to do the hard way. If you can spot an easy way of doing something, sweet, do it the easy way. Right, you can do it the hard way, that takes a bit more time. Right, that's the general way, takes a lot more thinking than writing, and you can do it the very general way, or you could just do it the easy way because you're already told that it works in the general case, so just do a specific case, see what happens. Anyway. Cool, bound reference size. There is a very good correlation between bound reference size and score. It's just the reverse. The bigger your bound reference, the worse your score, typically. Right? If you bring like the sum total of all of methods in this, you're screwed. Right? Because how are you ever going to find anything? But it also means that you are not confident about lots of this stuff. Okay? You can bring in a security blanket, make it a thin blanket. Okay? Use your tome of knowledge if you desperately have to for your practice. By the time you come to exams, there's almost nothing you should need to look up. Right? The more time you spend looking up, the less time you're getting marks. So you want it to be slim. As a general, the smaller it is, the better your marks tend to be. Optimization, so if you're trying to solve some x-intercepts for a quadratic and you first go to the quadratic formula, you're doing it wrong, princess. Right? You really should be trying to optimize. You should be able to look at something and go, can I factorize this a fast way? If yes, go, done. Right? If you're trying to kill flies with bazookas, so kill a quadratic with the quadratic formula, you're wasting time. Right? Time is so precious in these exams. You are almost certainly going to run out of time. You will not be able to go, I am very happy with this, I now give it to you. It's going to be like, time. Time. Fine, whatever. Right? You will probably want to write for longer than they will give you. Right? So you want to optimize as much as you possibly can. Cool. Good news, bad news. So there are 4 topics in methods. That's it. There are only 4 things that you need to know. The problem, so that's functions, algebra, calculus, probability stats. Problem is, I counted them and I've forgotten what it was. It was 20-something. That's methods in there. There's 20-something double-sided pages of dot points of stuff. There's a lot of stuff you've got to know. I'm not going to get through all of it probably. When did we start? 1:30? Yeah, I've got another half hour. We're basically on time. That's good. All the important stuff's loaded in the front because I need to get through that. This stuff is basically a quick dot point of a bunch of stuff. So, here we go. Geometry, this is assumed knowledge stuff. You should know this from like year 9 and 10, sort of basic stuff. So that's just a quick list of stuff that you should know. Cool. Linear and coordinate geometry. You are guaranteed every year to have at least 3 marks worth of this and probably more. Every year you are guaranteed, so you definitely want to know it. Parallel, perpendicular, / normal, same thing. M equals tan of theta, we know this. Yes, I'm told that this is something that's commonly missed by people, I don't know why. And distance formula, which is just a fancy way of saying Pythag, basically. So, if we've got this thing again, and that's probably going to look familiar from before, because it was another subpart of that question. This whole question is find whatever it was, the distance of AE. Yeah, find the length of A to E. You're going to need to do a whole bunch of calculus subbing stuff in. So you're going to do all of those things. It was just on that last slide. In this one question, it's worth 3 marks. Okay, you are guaranteed to have questions like this. Right? You're usually going to have subsets of it across the entire paper, but there's usually one question that expressly does just that. So you want to be really, really happy and confident with it. Polynomials up to and including power of 4. So quadratics, if you can't turn those into the pictures or the pictures into those, you have a problem because 1, that's like year 10. But other than that, you have a problem now because you've got to be able to do it. So that should be nice, easy stuff. Cubics, the same sort of idea. You should be able to switch happily between both. And quartics, the same. Make sure you know how to do this. Hypers and trunci, that's just straightforward. Like, you should know these. I should point out, I haven't labelled the asymptotes. You should definitely label your asymptotes. It's just the program I'm using doesn't do it. Because it assumes my own competence, basically. I can't assume your competence, so if you don't put in asymptotes, you've got a problem. Yep?
How close do we have to get to the asymptotes?
You have, what do you call it? Preempted. You have preempted my question perfectly. Fantastic. The good thing about asymptotes is, do you just do the line? No, you don't just do the line. You do your dotted line, and then what do you put? You label it, right? You write x equals 0 or whatever, wherever your asymptote is. That label tells me where it's supposed to be, right? So as a general, don't put it directly on the axis usually because it's hard to see, right? You usually just put it like a millimetre off, right? And then I know that you know, because you wrote x equals 0, I know where it's supposed to be. That's fine. So long as it is clear what's going on. If you put it like at x equals 1 and say x equals 0, we might have a problem. But so long as it's more or less there, it's fine. Someone in the last session said, can we use highlighter to do the asymptotes? I have no idea. Does anyone do that? No? I've never heard. You do? Okay, don't do it. I've never heard of it. And the reason I probably haven't heard of it is because these things get photocopied. So if you're doing that in yellow highlighter, it's not turning up. I can't see it. Therefore, I can't give it a mark. Right? Do it in something. Some people do like blue pen for the graph, red pen for the asymptote. Fine, whatever. It gets photocopied in black and white. I don't care. So just make it legible. That's about it. Cool. Don't do it like a wavy line for your asymptote. Don't do a dead line, as in a consistent line either, because that looks like an actual part of the function. That's another thing to watch out for on your CAS as well, is sometimes it will put in an asymptote line as an actual part of the line, and sometimes people lose the plot and draw that as part of the graph. So just be careful about that. Asymptotes should be either usually dashed. So make them dashes. Root graphs, even roots, odd roots. So even root, square root, cubic root. Start again. Square root, quartic root. So any even root should be one-sided. All your odd roots should be double-sided. Hopefully we already know this, yeah? Yep, good. Just sometimes people have and don't quite manage to put the second side on the odds. So, or sometimes they put them on, they'll put 2 on the evens, which is like, oh yeah, good work. Yeah. Cool, exponentials and logs, again, there should be asymptotes in this. You should just be able to sketch those happily. Trigonometric, we should know period for sine and cos is 2 pi divided by whatever that n is. Amplitude works for sine and cos. For tan, your period is pi on n every year. There's heaps of people that stuff that. Amplitude doesn't really make any sense for tan because you're off to infinity anyway. Cool, that's that. Transformations. Every year people suck at this. Don't know why. Like you do how many of these during the years? You do heaps of them. The thing that is commonly missed, and I hate this, but you can't use arrows to describe what the transformation is because it's not rigorous mathematics. Having said that, how do you teach it? Oh, I write arrows. But you can do that when you're making notes for yourself. So what I do is I put little notes down the margin of it does this, this, then this, then this, and I just write little arrows and numbers. Then when I'm actually answering the question, I use the proper language. Okay, so the stuff in brackets, that's the human language. The stuff otherwise is math language. Okay, you're in a math exam, you have to use math language. Something to be aware of as well is it's stuff like from the y-axis, not in the y-axis, because you can't be inside the y-axis. Makes no sense. So you use, like, most of this is common sense when you hear it out loud, but some people just put interesting things on. You can, I would suggest that you write it exactly like that, because that's the way that they want it written. But you can write parallel too, it's just you're more likely to put people offside, basically. So yeah, I'd suggest write it exactly like that. Don't put in the brackets. Right? The brackets is just for reference. So 17.2, there he is. So, for example, we have this function 2e to the x minus 2 gets transformed to 2e to the kx minus 2. Okay, it's worth 1 mark. Heaps of people didn't get it. Why? Well, there's a bunch of reasons, but it's a really nice, straightforward. There's only one thing that changed. There's got that k, right? So it's dilated by a factor of 1 on k from the y-axis. Short, sweet, easy mark. Some people decided to do all sorts of really weird things. Dilation of a factor of 1 in k in the y, there's that in the y-axis statement, which doesn't make any sense. Some people totally changed it into log base e of 2, which just made it really hard on themselves unnecessarily. And some people gave 2 transformations. It's like there's only a k difference. I have no idea where they got 2 transformations from, but they did. So yeah, you should be able to make your transformations pretty neat. Happily, rather. Cool. Transformations by matrices you should know as well. So that's just all the dilation matrices. We know that the matrix with the A, B, C, D, that's dilation matrix, and HK is translation matrix. We know this terminology. Yes, yes. People are nodding, cool. Same thing, proper notation. Proper wording. Otherwise, you just risk annoying people. So just put it in the proper one. You would commonly get away with some of the less perfect writing, but you don't want to be the one person that puts it in the lazy writing and that be the year that they decided, no, we're going to dock your marks for not putting it properly. So just write it properly. It will take you all of 3 seconds to write a sentence. All right. Doesn't take that much. How do you mean? There's a problem with that because what are your axes? X and Y. Does X reference a direction? Does it? I don't know. Depends on the question. What if X defines forward and backward for something? Oh yeah, it goes left and right. I'm in a Z-axis now. Right, so if you describe things in the positive and negative X direction or Y direction, it will always work, no matter what you do. So it's just the safe bet, no matter what happens. As soon as you start saying actual directions, left, right, east, west, some people write east, west, and it's like, come on, why? Why would you do this? Yeah, so, and like, because you can understand what they mean, but I can't interpret things for them, right? Which is, it's really annoying when some kids will write stuff and you're like, this kid clearly knows exactly what they're doing, just how they've described it is a little odd, but you can still, you know exactly what they're trying to say, can't give them the mark. They have to say it.
Is shift not an appropriate?
Would I accept it? Yes. Does it all? Are 70 people in the room all happy about it? No. You don't want to be the one that cops it because you use the word shift, and then that year there happened to be a majority of 36 people that said no, it has to be translate. So just what you got? How many extra letters? You got 4 extra letters. Right. For four extra letters, just give them this sookie translate word, fine, whatever. Yeah. Yeah. Was that everything? Oh, yeah. So this sort of stuff, for this one you had to derive, and then because you've derived and it's still a trig function, so it's going between sine and cos, you can actually get a matrix translation between the derivative and its original, which is one of those cool things. You have to be able to translate all of that. Right? It's not overly onerous, but a lot of people, many students were able to take the equations out of the matrices and rearrange them. Some attempted to draw graphs, but were unable to describe the transformations. So they could do the actual math, but putting it into the words that are required, they docked, which sucks because they pretty much knew exactly what they were doing. But at the end of the day, you have to be able to do what they want you to do. Okay. So transformations, you generally get allowed to do it however you want to do it. So x squared becomes this other thing, right? I would be overwhelmingly inclined to do that totally algebraically. Because you can just go, all right, I can factorize this thing, get it down into turning point form, and now I'm free to go for the transformations, and it's easy to write. You are welcome to do the matrix way. As you can see, that's about 3 times as long. But you're welcome to waste as much time as you want. Probably not an optimizing strategy, though. Yep. Define likely. I really hope they're not. That's unlucky. I would have to do an analysis across the last couple to answer that perfectly, but there is a fair chance that they'll rock up. Having said that, let me check. 16.2. They tend to turn up on exam 2 a lot more than exam 1. Yeah. I can't think of the matrix that's turned up on exam 1 for a while. But by that logic, maybe they've come due. You never know. Just know all the things, and then you're fine. What's the problem? No. Yeah. So, okay. You know that you're weaker at something. Address the weakness, right? Learn the thing as best you can. Hope for the best, sure, but address any weakness you've got. At least you're aware of it. That's the first thing. Unconscious incompetence is the thing that'll really kill you. That's that. Cool. Composite functions. We've got until 3, yeah? Yep. Yeah, I might need to go faster. All right. Cool. Composite functions. So you might have addition, in which case your h of x would only be defined where both of them are defined. If you've got the function within a function, then you're only going to have it defined where the range of g is in agreement with the domain of f. Heaps of people always stuff this up year after year. It's just a step-by-step thing. Take your x's, put them into g. If any of those x's don't work out, then you restrict your domain accordingly. Take the results from g, put them into f. If anything doesn't work out, restrict g and then restrict x again in order to make it so that it always works forward, and then eventually you spit out your h. Cool. This isn't overly difficult, it's just easy to stuff up. So take your time with it, think it through. When in doubt, draw something to give yourself an idea and to check, yeah, is this going to work for everything after this? Yes. Is it going to work for things between? Yes, no. If no, make adjustments. There will almost always be a question exactly like this, where there will be some interval of x that won't work. And it's going to be up to you to identify what that interval is, and therefore what restriction on x you have to have so that h is always defined for whatever domain of x you put in. For example, not that. Is it that? 1615a, yep. Cool, so I've got h is f of g, and then 2 is state the domain of h. So it's exactly that sort of thinking. And heaps of people, students appear to experience difficulty in determining the range of composite functions. Cool. A quick sketch over the given domain would have been helpful. Vindicated. So yeah, I've been saying that forever, and then it actually made it into a examiner report that I didn't even have to write. So that's telling you, draw a little picture. It helps clear your head and keep you on the right track. You should definitely be able to do domain and range stuff. Cool. Oh wait, there's another one. More domain and range stuff, same sort of thing. Oh, that's just about the inversing of the domain and range for stuff. Oh, no, sorry, not inversing. For it to be a subset, which I already had on the slide before. B double I, BC, struggle with determining its range, the domain, which was a proper subset. Yeah, that's more subset, so it's the same stuff. Same stuff, just more examples for you to look at in your own time. Cool, inverses. The two black things are the same as each other. The two reds are the same as each other. The red and the black are not the same as each other. Make sure your notation is good. Inverses are geometrically, they're the same as flipping across the x equals y line. Something that I lost the vote on last year or 2016, it was one of the two, I can't remember. I lost this vote. They want you to write, when you're trying to figure out what the rule for the inverse is, you swap x and y. We're all familiar with that, yeah? On one particular thing, they wanted you to write either swap x and y or x goes, like x switch y, to say what you're doing, okay? It takes takes 3 seconds to write that. If you're doing it, just write that to be safe, because I lost the vote that year and you had to put it in, which I wasn't too happy about, but can't win them all. So yeah, it had more to do with because of how the question was noted, the notation of it, which is 16.1. Yeah, it's that question. So it was 2016. Cool. Anyway, so the domain and range switch for them. This will only be automatically defined if it's a one-to-one function. If you don't remember what a one-to-one function is, go back to year 11, remember it. Usually, though, it won't be automatically defined. It won't usually be a one-to-one function deliberately because they want you to define a domain such that the inverse exists as a function. So this one, a lot of this probably should have been more than 50% marks. The thing that really threw out people was, so if you see about halfway down, it's got y equals plus minus this. That's not a function. That's a relation because they didn't restrict the domain afterwards. Some of the ones that did restrict it made it a positive instead of the negative because they didn't look at what the question was asking for. Because if you look at the very top left, k is defined for the negative side of this log. Yeah, so they actually wanted the negative one. And then the final thing was, even if you wrote y equals the negative root e of x minus 1, the original function wasn't y. The original function was k. So you had to write k inverse is this. So there are a lot of ways to lose a little mark in there. Yep. Change x, y, fine. Just so long as there's some indication of x, y being flipped, that's fine. The reason it came up in this one is because anywhere in that question does y turn up? No. And so you are newly defining this y when you're not putting in the thing that's saying swap x and y. That's, which I reckon is tedious, but I lost the vote. So, yeah. Anyway. Yeah, cool. All right. Also, if you're trying to find the intersection between a function and its inverse, it's almost always going to be on the y equals x line. There are exceptions to that, and I suggest that you go poke around and try and find them. But those are usually due to relational problems. They'll be on the y equals x line, so just solve the function equals x or the inverse equals x. Massively chops down on your working time. Much, much easier. Cool. Odd and even functions, we should know what they are. Not all functions are odd or even, though. It's possible to be neither. And that's the functions bit done. Algebra. Here we go. All right, simultaneous equations, you should know how to do for 2 and for 3 variables. If you can do it for 4, congratulations, then you're fine, right? That won't turn up. You'll only get 2s and 3s, but you should know how to do it. You should know how to deal with it when there's no solutions, a unique solution, or when there's infinite solutions. You can use matrices or algebra or the geometric methods. In my particular case, I find it easiest to start as matrix and then jump across to algebraic, right? Because that's the fastest, almost always. But you can do it whatever way you want. Right, is that everything? Yes. Cool. Trig, exponentials, and logs. You should be able to recall all of your trig values immediately off the top of your head, and then jump around the quadrants to make them positive, negative accordingly. I would suggest, and this is not something that commonly comes up, but it makes things a lot easier for you. Memorise the powers of 2 up to 10. Memorise the powers of 3, 4, and 5 up to 5. And memorise the powers of 6 to 10 up to 3. Okay? Will they all turn up? No. Will some of those turn up? Yes. I can't tell you which ones. I don't know. So just know them and you're good. You don't even have to strictly know them. So you don't necessarily need to know 7 cubed is 343. You don't have to know that. But if you do and 343 turns up, you'll probably, somewhere in the back of your head, and you're like, that's 7 cubed. That might be useful. Because usually when you get perfect numbers like that, it's not a coincidence. It's probably going to turn up somewhere in the working somewhere. So you've already got a hint that this is probably going to be useful. And other times it stops you doing dumb errors. So general solutions. So 16, 1, 2b, 1, 2b. Why have I done this? I forgot. General solution. Okay. This was using that tan theta equals m stuff. And just knowing when to give solutions. Some kids gave general solutions for this, and it's like, no, champ. I just want what is the angle as measured from the positive x direction, so in an anti-clockwise direction. So it should just be 150 degrees. Some left it in radians, which was a problem because it asked for it in degrees, I think. Oh, no, you were allowed to do either for this. No, sorry, for this one you were allowed to do either because it didn't strictly specify. But some people gave infinitely many answers. And yeah, you could, but don't. Right? It only wants one. So yeah, just stuff like that. And then alternately, being able to give general answers made this question a lot easier. I am sympathetic to a lot of these people because originally that question looks a lot more like a special question. But it's not. Because all it wants you to do is solve some basic stuff. And you just had to make a really cheap substitution. When I first did this, I accidentally solved question 6b when doing 6a. Right, which seems weird, but because it says after that, hence find all the possible solutions to this, all I did was I saw that equation and I just solved it out of just, oh, okay, solve, yep, great. And then I read the next question. It says, find all the solutions for this. I just did that. What? So I read the question again. It's like, oh, I should probably follow my own advice. Actually answer the specific question. So yeah, I'm a little bit empathetic, but that's a good trig question. Heaps of kids, they saw that and basically just went, yep, I'm out. Next question. Which is, yeah. But basically anyone that got 6A pretty much automatically had a freebie at 6B because you got 25% of them got a full mark there, 25% got 2 marks there. A little bit suspicious. So yeah, that's that. 17.2 multiple choice. Find the value of B. Oh, if you can do the general solution to this, this solution becomes really trivial. It becomes really quick and easy. It's only when you try and do it for limited things that it becomes a bit more fiddly. A whole lot of notation issues that come up. Log base b of x is not the same as log b of x. Mary will burn you at the stake because she hates it, particularly for log base e. She says loge is not a thing. And she's absolutely right. Loge is not a thing. I personally don't care because if you write L-O-G-E of X, I know what you're writing. But she's like, no, has to be a subscript. I'm like, fine, whatever. So that's one of those 5% things that I don't particularly care, but she will like spear me if I tell you otherwise. Other stuff is then, so people hear that one, that, it has to definitely be a subscript, and so they'll put X as a superscript. It's like, no, just because one has to go down doesn't mean the other one has to go up. Right? Just write it properly. As another side note, which will come up in a second, you don't have to put the brackets for log base b of x. You don't have to put brackets. I'd suggest do it anyway as a matter of good practice. The x plus y and then the x plus y, those are two different things. Right? The one on the right has log base b of x plus the constant y as opposed to the other one. Right? If you don't read the difference between those, that's a problem. Right? So I suggest put in brackets if, 1, make it easy for me to read, 2, make it easy for you not to make a dum-dum error. And then the last thing that people really like to do, every year I see this, they decide that, a log is a multiply. I can just cross all those logs off. Like, no, you can't, champ. It's not a multiply. Cool. That happens every year. Right? You are bound to get a question just like that at some point. And you desperately want to cancel off those b's because the x, the y, and the z won't just be x, y, z. There'll be entire terms of something in there. And you're like, oh, I really want to just, yeah, that's good, that's good. No, don't. Right? Just because you want to do it doesn't mean it's valid. Beautiful. Inequalities. This is something that commonly goes wrong for people. So, obviously 2 is greater than negative 3 and negative 2 is less than 3. To get from the first side to the second side, I've multiplied or divided by a negative. Whenever you do that, the inequality should flip. Right? That's just there as a proof to show that it definitely has to be true. Okay? Heaps of people forget to do that. When in doubt for these things, just run it as though it was equals and then just check at the end which way around it should be. Right? Even if you do it as a less than, greater than, do a check at the end just in case. Right? It takes a couple of seconds, saves you a dum-dum. This also holds true for logs and exponentials. The inequalities can be slightly less than intuitive sometimes, so just check. With that example there, that shows you why. Be super careful about greater than, less thans when you have composite functions going on, because it's very easy for that stuff to go, well, for this domain it's this way, for this domain it's the other way, for this domain it goes back again. So just be careful. Calculus. We are almost there. Those things, that's your formula sheet. You should never have to look at that. There's only, there's one thing that you might have to look at, which is the derivative of tan, unless you do spec, in which case you know it off by heart already. That's about the only thing. Everything else you should just have that committed to memory, just by, not by rote memory, but by practice. You should have done this so many times that it's just, you never have to check again. Same with the product rule and the quotient rule and chain rule. You've done them so many times, you should never have to check them. If you desperately want to for security blanket, fine, check it, but it's wasting time. Every year, question 1 will be, there'll be one chain rule and then either product or quotient, or the product and quotient will be joined with the chain rule in some way. So you want to have that down pat because those are free marks. Be careful with, because they're always worth 2 marks each, so part A is worth 2, part B is worth 2. If you only write an answer, well, now we've got a problem because that's 1 mark. Even if the answer is perfect, right? The answer is perfect. And these are, like, a lot of these you can just do in your head in 2 seconds and just write because they're freebie marks. Give me something to justify the working. It doesn't have to be much. You can usually just write U equals this, V equals that. Right? No, you don't even have to derive it and join it or anything. You just go U equals this, V equals this, answer. I can justify giving you both marks now because you have clearly done whatever it is that you needed to do to get there. It's just something to avoid that because that definitely has happened before where I've had kids get really close to perfect marks and then they've done stuff like that. It's like, oh, I'm going to get in trouble if I give this full marks, even though I'm very certain that this kid knows exactly what they're doing. That first one, do we know how to integrate that? Yep. Oh, sorry, let me rephrase. If you're spec, don't answer. The people that are only doing methods know how to integrate that first one, the 2x over x squared plus 1. Yeah, you sure? Integrate it, go. Go, go, integrate, go. Faster. When you're done with that, integrate the next 2 and see if you notice anything interesting. Don't simplify the third one either. Just integrate it how it is by the same rule that you integrated the first one. Some methods people might be figuring out that they might not know how to integrate that first one. Would that be true? Yeah? Okay. There is a rule for that where if you have the derivative of something on top of the thing, right? So notice that the top is the derivative of the bottom, right? If you integrate that, you get ln of absolute function of the bottom thing plus c, right? If you're not aware of that, put it in your CAS and stuff, write this stuff down, or come find me afterwards and I'll write it down properly for you. That's not on that formula sheet. Right, so that's one short thing to know that's handy. Right, if you're spec, you definitely know it. Right, so it's not difficult at all. The thing about the second and the third thing, if you integrate those using that same rule that I just said, you'll get an interesting result. One will be ln of x plus c, the other one will be ln of 3x plus c. And that seems inconsistent, right? But that factor of 3 gets smuggled into the plus c, right? Which I'll allow you guys to play around with at home. Because you've got this on the sheet, so you'll be able to fiddle around with it and figure it out. Don't forget your plus C's and don't forget your DX's. This is one of those 5% things. Mary hates it when you forget the DX. I don't particularly care because pretty much any integral you're going to write in methods is going to be DX. So it's very heavily implied, so I don't particularly care. Mary will kill you. So, and she's the chief examiner. So almost every year she will find that mark to disappear if you drop it. So put it in, make sure it's there. When you get into multivariable calculus, it definitely matters that you have your notation, but for methods it don't so much. Cool. Limits and first principle and derivative problems. So you should know how to read limits. This thing would be a pain in the ass because it is not continuous and it is not smooth. Right? So knowing what all that stuff means. If I take a derivative of this function, are we in agreement that I would get x plus 3? Oh, it's the afternoon, your brains are going slow. Yes, no, I abstain, anything? Yes. X plus 3? No. Whose brain stopped working? There we go, okay, right. Factorise the top, you get x plus 2, x plus 3, can cancel off the x plus 2s, yes? Cool, so I'm left with x plus 3. So should the derivative, Jesus. Should the derivative be 1, I should have said?
Yes.
Right, the derivative should be 1, right? Yeah, you're all wrong. Okay? Because the derivative should be 1, except when x equals negative 2. Right? Because that thing is not defined at x equals negative 2. Be careful about those things where you lose a piece of information when you've derived. Most of the time in methods it won't turn up, but you don't want to be the one caught out. So you just have to worry about that. So yeah, undefined problems. Average rate of change versus average value. Hopefully we know the difference between these two things, because in 2016 I didn't really believe Mary that most students are idiots. And then I saw this question, I was like, yeah, no, all right, I'll give that to you. So, question 6a, calculate the average rate of change. Question 6b, calculate the average value. They are literally on the same page, A and B. A few students confused average rate of change with average value. How you do this? How you do this? Okay, that's definitely me that year. It was definitely Mary that year, because it wasn't just once or twice. This was like, it happened surprisingly commonly. It was pretty common for kids to do the wrong one, read the next question and go, whoop, and then put arrows. Fine, you recognise the error. Some people didn't. It's like you automatically lost 2 marks because you've done the wrong thing for 2 different questions. So it was just dumb. Know the difference between the two. Okay? Yes, they sound similar, right? They are different. Average value, average rate. Different. Curve sketching, derivative equals 0 will give you a minimum, a maximum, and or an inflection, right? Heaps of people forget about those inflections, so when they do solutions, they forget to consider, is this an inflection? The strictly increasing, decreasing terminology, that probably won't turn up again, but last time, and I lost this argument, and I think Mary was the same as me, they ended up accepting 0, even though 0 is necessary. If it's a 0 gradient, it's not increasing, and it says strictly increasing. So yeah, if it says strictly increasing or decreasing, then 0 last time was accepted, so I would expect that it is accepted this time as well, because we got outvoted last time, which makes no bloody sense, because 0 is not positive or negative. To do curve sketching, it helps to know how to do double derivatives and how to read them. So if you're doing spec, you obviously know how to do this already. If you're in methods, it's not part of the course, it's helpful. Your call whether or not you want to learn it. 1615 AV. So for questions like this, find the stationary points and state its nature. So you're talking about maximum, minimum inflection. With that second derivative, it makes it really quick and easy to do. But you can do it other ways. Tangents and normals and perpendiculars, you should know these things, how to switch between them. There's that m equals tan of theta again, because that was a missing piece of information for a whole lot of people. You are guaranteed to have marks for this question. Wrong one. That thing. Cool. Kinematics. You should just know these, basically. The one thing to be aware of is as you go in, so derive is down the left, integrate is up on the right. The one thing to be aware of, the plus c. So if you're going from acceleration to velocity, your plus c represents the initial velocity. Right? Hopefully we know this already. Be careful, because if you're going from acceleration to displacement, you're going to have 2 plus c's, which is no good to you, because you don't want plus 2c, because they're 2 different things. You might have plus c plus d. Well, that becomes a bit confusing, because now you've got a plus d on displacement. Right? So I don't care what method you use, so long as you've had a bit of practice with it and you're consistent. That makes sense. So it's just something to be aware of, because that commonly gets stuffed. Find this and hence find this. There are many integrals in methods that aren't covered, which is the one that I showed you before. Is it on there? Yeah, that one.